Ladies and gentlemen, hello and welcome to the webinar Menus Implementation in IBM Rational Hats. It's part of a webinar series program organized by Royal Cyber for increasing awareness and sharing benefits of IBM Host Access Transformation Service or HATS. This webinar focuses on the menus, their types, Royal Cyber different menus implementations according to the client needs and project specification. In the end, we will demonstrate the development of a menu via web service. I am Yasir Hassan, and with me I have our head specialist, Mr. Asif Hussain and Mohammad Imran. Thank you very much for your overwhelming response. Let us start with the agenda. We will start off with a brief introduction about us, that is Royal Cyber. We will move on with the discussion on the IBM Rational Hats tools. In the next section, we will touch upon the types and variants of navigation menus. Then we will present sample of our different menu implementations, the situation in the particular projects which led to the eventual menu design. We will conclude with the demonstration of development of HATS menu implementation with a web service. We will try our level best not to get too technical overall, but the last section obviously requires some development background. Let us start with a brief introduction about us. Royal Cyber is a modernized e-business solution provider. We are IBM Premier Business Partner, IBM Authorized Trainer, and Microsoft Certified Gold Partner, and we have presence in many countries across the globe. Since the company's inception in 1997, our experts have been leaders in providing training and consultancy of IBM Rational, WebSphere, Tivoli, Lotus, Cognos, and Microsoft Family Solutions to businesses worldwide, including many Fortune 500 companies. These are a few of our objectives, as you can see on the screen. Basically, we strive to create win-win situation for our clients and help our customer achieving the best ROI at minimum cost. This is our global footprint. We are headquartered in Chicago, and we have offices and development center across North America, Asia, Europe, Africa, Middle East, as you can see in the slide. Here is our brand portfolio. As you can see, we have covered all the possible bases with our solutions from enterprise modernization to database servers. As you can see, in enterprise modernization, we have IBM Rational Hats. In databases, we have SQL Server, MySQL, DB2. We also have Oracle in our repository. And then in e-commerce, you can see we have WebSphere Commerce. In Microsoft, we cover almost all their solutions. So basically, it's a comprehensive coverage of, every possible need, every possible IT need of a customer. Okay, now we will discuss IBM Rational Host Access Transformation Services or HATS briefly. Rational HATS is a premier IBM product suite that is inarguably the best tool for presenting old green screen applications built on legacy servers like IBM I, IBM Z in modernized manner, very rapidly and efficiently. HATS modernized version can be prepared for various output mediums. You don't need to make any changes in the existing application. Basically, the green screen applications are very mature. They have passed the test of time. So the idea is that it stays on the back end working as it is working for many years. So we don't, make any changes on the green screen. Rather, what we do, we make changes on the front end. That is the HATS layer. It's obvious, it goes without saying that you don't need to migrate data when you're implementing HATS on top of a green screen application. And it is very hard to train people on old obsolete technology. So moving to HATS permits new resources to come on board quickly because they don't need to learn the old interfaces. They work on the familiar interface, that is UI of the day. So it's very easy to support your green screen application if you have HATS implemented on top of it. Okay, So data from legacy server like system I and system Z can be used at various places once you have implemented the HATS layer. Data once processed by HATS can be deployed for web application, rich clients, portals, and mobile devices. You can also create and consume web services for back and forth communication with any other system, database, or whatever the situation is. HAT does not only display the content of green screen application on the modernized interface. It's not always about just displaying the content of green screen and directly mapping it on the modernized interface. There are so many things that HATS can do, like modernizing green screen per the recent UI standard. You can use macros to cover the functionality of multiple screens into one screen. You can apply customization, and there are so many other techniques to show green screen data in organized and friendly manner. Advanced controls and widgets can also be used, like calendar controls, which were naturally absent in the green screens because there was no concept of GUI in that time. HATS can also be used for creating mobile version for specific devices like iPad, iPhone, your Galaxy devices, or even the barcode readers, the very special purpose devices. Basically, it all depends on the business need of the customer. This is the overall architecture of the HATS implementation. You can see that IBM I server is used for the green screen application. The HATS application is deployed on the WAS application services application server. It's WebSphere application server. And then once we have built this platform, it can be used on various places, various browsers, various devices via HTTP protocol, web services, or JDBC connection, or whatever. Okay, before I hand over the mic to my next fellow presenter, Asif, let me remind you that this webinar only covers the menu implementation in HATS. This obviously is just a fraction of the overall HATS feature. Listed on the screen are few of our training session details. The distance learning workshop, that's the one on the top. It's a 2-day long workshop where you will learn the HATS development from scratch. Other than that, we also offer online and on-site instructor-led training. The curriculum for the workshop is fixed, the distance learning one, but for the ILT sessions, we can have customized curriculum as well. And once you register for the ILT, you can ask us to build the customized curriculum, including items other than rational HATS as well. So you can find the URL for each in the chat box, and we will also provide it to you in the email. So over to Asif.
Thank you, Yasser. I will start with the introduction to different navigation menus implemented in HATS or in general web development and their benefits. In the context of computer applications of all types, menus are options that permit a user to perform various operations for retrieving information or initiating a functionality. Generally, we associate the menus with the mouse click, but in a broader scheme of things, the menus could be accessed by choosing, selecting something, or even providing some text. Menus are essential, perhaps the most important component of menu-driven programming, which is arguably the norm of the day. Menus make the navigation easy and make the screen look less cluttered. There are numerous types of menus and their subtypes. Even on the modern devices like smartphones, menus have not lost their importance. The way they are presented is changed, but menus are still there. There is no menu that can be called the best. It is always the situations like interface, number of options, consistency with the application, client requirement, device being used, and etc. that needs to be considered while deciding the menu to be implemented. Like many entities in computing, menus also lack standard definitions. However, essentially there are two types of menus, static and dynamic. Let us discuss each one of them briefly. Static menus have fixed content and ideally are not supposed to be expanded or collapsed, as all the contents are displayed all the time. As every option is available, so there are no levels to explore for navigation. The contents are not picked dynamically, so there are no changes for particular user type or situation. Static menus, through a simple but not bad, they are simple but not bad all the times. There are certain benefits of static menus, like they are computationally very light, they look simple. Programming for static menus is also easier. However, there are few drawbacks as well, like lack of flexibility, as they are fixed, so the screen space has to be allocated to them all the time. If their roles and rights are dynamic, static menus are very hard to implement. In that case, if there is some change required, it is always necessary to open the code and go through the whole development cycle of changing the code and reviewing and testing it. If the contents are known in advance and are not expected to be changed, and there are no or very less changes in menu items per user role and rights, then going for static menus does make sense. Furthermore, if the development time is very short, then static menus come in handy, as they can be developed very quickly. Dynamic menu, on the other hand, as the name suggests, is dynamic and may change at runtime according to particular situation, like different user rights, different state of options. For instance, right-click on a MS Word file has different options as compared to, say, MS Paint file. Through its various implementations, dynamic menus can be programmed to appear as and when needed. Their depth can be of any level. Menu contents can be obtained through interfacing with database or with some web services. Dynamic menus also have their advantages and disadvantages. Major benefits are their flexibility. Dynamic menus give user an ability to place the menus anywhere on the screen in some cases. For future enhancements in the menu and changes according to roles and rights of the user do not always require programming of the whole thing. Major disadvantages are complexity to develop and possible performance degradation on slower bandwidth. If the contents are not known in advance, or there are frequent changes in the menu items, or the menu items are different drastically for user base, then going for dynamic menus is better than static. There is no silver bullet as far as menu choice is concerned. It is very important to analyze carefully and don't go for the overkill if static menu can work adequately. Again, there is no specific definition, but generally the menus menus can be divided into these subcategories: context or pop-up menu, drop-down or pull-down menu, tree menus. Let us discuss each one in detail in the coming slides. This is the most commonly used navigational menu type, where we have a heading item on top, which may or may not be clickable, and then we have child menus. The levels of drop down could be any, but usually it is considered friendly to have 3 to 4 levels at max. Context Can you hear me now? Okay. So sorry for the inconvenience. There were some network problems here, due to which the connection dropped for a few seconds, and my voice was not reaching you guys. So let me continue from the slide we were on. It was about context or pop-up menus. As the name suggests, pop-up, it pops up when user performs particular action like mouse click or hover, and context is very important in this case, as the same operation based on the situation, different situations can have different options, like a right-click operation on a file and a folder gives different options. Tree menu is another very important menu type. It works like Explorer option in Windows. It is considered useful as user can expand or collapse the section they want to work on particularly. There are various reasons why we need menus in HATS applications. Obvious reason is modernization. As the green screen application is modernized, menus are essential part of the modern GUI design they call WIMP, Windows icons, menus, and pointers. It is very difficult to navigate on green screen due to lack of GUI. HATS finishes the need for the user to remember the IDs to access the menu items. It makes application user-friendly and makes training very easy, which is a very cumbersome task on green screens. Sources of menu. Choosing a specific menu type depends on lots of variables like need, situation, client's requirement, etc. This slide provides an introduction to the process of choosing a particular type of menu, but it is only an introduction. There are lots of factors on which such decision making has to be performed. So if the menu is static, that means for all the users and situations, the menu remains the same, having fixed menu items and actions. We can go for direct mapping of green screens. In fact, direct mapping of green screens is mutually effective in dynamic or static both types of menus. With static menus, all sorts of client-side menu scripts like tree, drop-down, or any other menu can work with fixed HTML, JavaScript, etc. While for dynamic menus, the dynamic items behaving based on the situation and user roles along with direct screen mapping, we can create menus with the data collected from DB calls, database queries that means, and we can collect data by running HATS macros, or we can use a web service to get the menu items and their actions for certain users' session. JDBC and web service, this is the slide about like how we can use them to get the contents of a menu. So here's a way of creating dynamic menu. This is how we can produce a menu that will display options based on the user's roles and privileges. When a user signs in, HATS executes a piece of code that does dynamic menu generation. That means sign-in triggers a procedure that connects to the host system's database or calls a web service that responds with the menu options available for the current user. This record set or XML response is read by the HATS code, and based on it, the HATS application generates HTML menus. Directly mapped menus. Directly mapped menus are simple menus equally useful in dynamic as well as static HATS menu generation. In this method, we generate menu screens on the fly based on the menus on green screens. So this means whatever menu options are being displayed by green screen in a certain situation, the HATS modernized web screen shows the same options. The only difference it creates is in the look and feel of the screen and the clickable behavior of the option. These directly mapped menus can be created by two approaches. One, just like any other screen in HATS, one is screen customization based, and the other one is default rendering. For screen customization to take effect on a particular green screen, developer sets screen recognition criteria that HATS uses to match menu screens or in fact any host screen. Host screens can be recognized by any combination of criteria, including how many input fields or total fields are on the screen, the coordinates of the cursor's position, or text strings on the screen within a defined rectangle or anywhere on the screen. So anything on the screen can be treated as a screen recognition criteria to take effect a particular screen customization. When a host displays a screen, HATS searches to see whether the current host screen matches any of the screen recognition criteria developer has set in. Any screen customization in the project, if HATS finds a match, the defined actions for the screen customization are performed. Else, if screen is not recognized, global rules are applied, and based on them, the screen or menu is modernized. Now we'll see how macros are used for menus, and macros are easy to generate in HATS and are very powerful. You can skip and combine screens or enter data on behalf of the end user. Any series of keystrokes can be captured in a macro and can be played whenever required. Macros can help us navigate to a certain screen when triggered. For menus, macros are pretty useful too. Based on the nature of macros used in hats for menus, they can be divided in two segments, pre-menu macro and post-menu macro. Here you can see a pre-menu macro. A pre-menu macro is described in diagram, which is described here in diagram, is used to collect menu options data from several screens before hats can use it to generate a modern styled menu by JavaScript or by any other means. So what it does is it is on a certain situation, a macro is triggered, and it goes through a certain set of screens and collects different menu options from the green screens and put them into some sort of an array, and then it displays it in a certain format later on when needed. So this macro is used to collect the menu items data. Here you can see a post-menu macro. While a post-menu macro is the one that is used to accomplish the actions required to be done as the result of the chosen menu option. For instance, on clicking a menu option, the application has to jump to a certain screen that can be made available on the host after passing through 4 or 5 different screens and providing different keyboard inputs to get onto target screen. Post-menu macro will provide all the required inputs to the host and bring the target screen in action. Now we will discuss the strategies one needs to take for mobile devices for the implementation of menus. So here you can see, in fact, we will discuss all sort of strategies for all sort of devices here. Here you can see a situation. This is an actual situation we experienced and provided solution. In fact, all the solutions we'll discuss here are actual solutions, and we'll discuss them, that what was the problem, what was the situation, and how we provided the solution. So it's a simpler one. Here, in this situation, we had limited number of menus. In fact, single menu was there, and there was very little variation according to the user types, and there were no submenus. So it was a pretty simple menu, as you can see on the screen. What we did, we fetched the menu items available on green screen and applied customization technique to show those items as GUI-based icons. Icons are shown instead of textual statements. We had in green screen for the user navigation. Green screen is replicated, but the customization to show the icons of the items available to the user. So you can see here that this was the transformation we made, and instead of each menu item that was a textual menu item, we replaced it with an icon, and these icons are shown on the screen based on the user's role, actually, because the green screen was showing these menu items based on the user's role. What we did, we replaced that individual menu item with a single icon, and so we didn't have to do any dynamic programming for the menu by ourselves, and all the role-based programming was done at the green screen as it was. So green screen shows the menus according to the user's role and rights, and we display them as is. but in modernized manner, of course. However, this is a relatively simpler situation. Life is not always that merciful, as you will see in the subsequent examples. In this case, we had text-based menus on the green screen with an ID written with each under each menu. We had some menus. You may call it a nested menu as well. User has to access the screen by providing the ID in the provided field at each level. The menus are populated based on users' roles and rights. We implemented the direct mapping with green screen. Green screen is already showing the menu and taking care of the user roles and rights. It means it is only showing those menus to the user which he or she can access. So we replicated the menu screen as is, but in modernized manner, of course. So this is how the modernized screen look like. Here you can see the modernized menu. User can still access by providing IDs, but the menu items are clickable as well, which makes it very convenient for the end user to browse through the application. There's this another situation, another case. In the green screens application, users were provided with the menus on the main screen. The menus available to the users were according to the roles and rights at each level. However, at the same time, few menu items were fixed for the entire user base. Considering the fact that we had to tackle the whole roles and rights scenario, we studied the possible implementation of the menus to be implemented in HATS implementation. As we had observed that few menu items are consistent across the board for each user, whereas few are available to users with specific roles and rights. We designed the screen in such a manner that the fixed item for every user that are fixed are displayed as static menu or on left side, whereas top menu bar is populated dynamically based on users' roles and rights. Here you can see the eventually implemented screen. Observe the left and top menu as mentioned in previous slide. So you can see one of them is fixed and the other one is dynamic. Here's another situation. In this, we had same options available to every user of the system, but there were differences in the operations the users can perform under the available options. Navigation was complex as it is very common with the green screen applications. We changed our general approach in a bit and made the operations that user can perform as our menus. We recorded the navigation patterns for each operation and then presented the options on the main screen. When user clicks any option, the macro runs on the backend and performs the navigation required on green screen, and user is reach to the screen to perform desired operation. On front end, the whole lengthy navigation is avoided and user only requires to perform the eventual operations. That means this increases in the efficiency of the user. It saves time for him. Here's the final modernized implementation. Interesting this to observe here is that instead of navigational menus, direct buttons are provided to perform the particular operation directly, as the need of navigation is taken care by the implementation of macros. In this situation, navigation was really complex. User has to access these screens by keep on providing four IDs of length 4. Overall, the depth of menu or the depth of the menu was large, up to 5 levels in some cases. There were differences in the screens available to the user per their roles and rights. The solution we created for them, that menu, because menu is dynamic based on roles and rights, we created a JDBC connection with DB to collect the menu options available to the user along with the hierarchy. Then we displayed the menu contents in the form of tree by using JavaScript or jQuery, and tree menu widget was used, as user can click directly on the available menu or can also click anytime while on the screen. We play macro both ways. For instance, if a user is working on a screen and suddenly clicks some option in the tree, the macro at the backend exits and user from the screen from the screen on which he was on, the macro is run to navigate the user to screen she clicked on the tree menu. As you can see here in the modernized screen, the menu is looking less cluttered, especially there are many sub-levels, but because of this pre-menu structure, the screen is looking less cluttered, and many of the options available to the client are hidden most of the time, saving space. Host screens navigated by entering 4 character IDs is another situation here, that host screen was navigated by entering 4 IDs to access the desired screen. Navigation was not for more than 3 levels in green screen. Different screens were available with respect to users' roles and rights. It is the same situation as we had in the last case, but the only difference is that instead of making a JDBC connection, we used web services to get the navigational menu items in XML. So this is a situation that we'll discuss in detail in the implementation section of our webinar, where Mohammed Imran will guide you how we can develop such an option with hats. Here's another situation, another case we resolved. There were multiple static level menus and different for user base with respect to roles and rights. Deep navigation was there, like up to 4 levels. Few options are used more frequently than the others in each module. The solution we came up with, the menus are dynamic and populated based on the roles and rights of the logged in users. So we created a JDBC connection to pull the complete hierarchy of menu items according to the user's roles and rights and populated it into multiple levels with JavaScript based drop down menu. Along with that, the search functionality is provided to search a certain menu option for making the navigation further convenient. Just like in the Windows 7 start menu, we have a search functionality. You can see the eventual screen that we came up with here. Observe the scroll bar appearing at the last slide, last level. You can see here. There are some options at the last level that are not available on the screen, and arrows are given at the top and bottom. And these options, all these options are picked up by a web service call, and they are JDBC call, in fact, and they are presented like this here. Now let's see another case. Multiple level of static menu was there, different for user base with respect to the roles and rights. Up to 4 levels of navigation was there. Few options are used more frequently than the others according to the module user is using. So this is the difference. Like there is this most frequently used options section according to the module user is in. So the menu is different with respect to roles and rights and with deep navigation. So the solution is, and this is, observe this solution. We don't have this on this screen, so we can see the solution on the next slide. Let me. Okay, here you can see the scroll bars are appearing at the last level of the menu, and their menus are dynamically populated based on roles and rights. Eventual level of the menu is displayed in a floating widget with list of options from the module user is currently using. User can place the floating widget anywhere on the screen, so it is not occupying much space. He can place the widget as per his convenience. Along with that, the search functionality is provided to search a certain menu option for making the navigation further convenient. Here's another case, multiple level static menu, different for multiple level dynamic menu, in fact, different for user base with respect to roles and rights, deep navigation again. Few options are used more frequently, like the last menu. But the requirement changed here is that the client wants an iPad version of the menu. So there was no change in the way we pulled the data as we had in the last menu implementation, but considering the space or in fact lack of it on iPad, we went for a pop-up menu that could be placed anywhere on the screen. It is hard to navigate via drop-down menu on the tablets, so the menu is provided in the form of tree, and frequently used widget is provided separately on the screen. User can minimize, maximize, hide, close, drag the menu as per his convenience. Here you can see that menus are provided on both sides of the screens, but user can hide, maximize, minimize, or move the menus anywhere. Now I am handing over the mic to Mohammad Imran, one of our finest hats developers, to give you demonstration to build a menu using web service. We also call him Dr. Hats due to his expertise and firm grasp over Hats affairs.
Thank you, Asif. Today we will build menu using web service. We have tried to keep it very simple, but obviously you need to have development background to understand. As we have already discussed that menus can be created from mapping of same menus on green screen. Menus content can be picked from multiple screens using macros. If menus content are dynamically changed according to user roles and rights, JDBC or web service can be used. Choosing a menu is dependent on green screen behavior, project requirement, and other such variables. For example, in our requirement, green screen are navigated using 4-character ID, and these IDs are different for users according to their roles and rights. IDs sets are stored in database for each user types and in some cases for individual user as well. So in this scenario, we have chosen to use web service to populate the menu content. Same could be accomplished with JDBC connection as well, but as on the destination we had the web service implemented, so we went for web service instead of JDBC. Anyhow, we initiate a request to the web service by providing user ID and password. Web service returns the set of business logic need to be executed upon sign-in event of the user. So on the slide you can see that an XML response is returned by the web service. We will use XML to generate menus using this response. Here we can see subsystem menus, submenus in parent-child hierarchy. For the implementation of the menu, we have created a menu handler class that implements the content handler interface. As the SOX events are filed in the XML document, it notifies our program to take appropriate actions. The SOX API specification primary task is to create a class that implements the content handler interface. It is basically a callback interface used by XML parser to notify our program of SOX events as they are found in the XML document. We have to create a JSP name like menu.jsp, which also use JavaScript to generate menus. Menus.jsp need to be included in template to simplify the menu codes. Otherwise, you can write this JSP's code in the template too. When the menu.jsp file runs, it fetches the attributes of menu HTML, which is basically a string buffer that contains the necessary HTML code to display the output to the user, that is menu in our case. If the attribute exists already, menu HTML is printed out to display the page to the user. However, If no attributes are returned, SOX parsing come into play. It performs some action like a new SOX parser object named reader is created, as you can see in arrow 1. A new object named handler is created from the menu handler class, as you can see in arrow 2. Next, the content handler is set when the handler is passed to the reader. The location of our menu XML object is passed to a newly created URL object. The XML is now passed on the reader object. Next, a method from our menu handler class object menu HTML is called. As you can see in arrow 3, it returns the menu HTML string buffer that contains all the HTML code generated by the class file as a result of the firing of different events. The methods that are used to identify the different elements of our XML are start document, start element, end document. The start document method marks the start of the HTML code. It defines code to create the top menu, for example, creating div and table tag, etc., its positioning and style. The start element method makes use of the local name and attribute parameters from its argument. When any of the subsystem is selected, the local name variable is loaded with the value subsystem, which correspond to the subsystems defined in the XML. Upon encountering this event, the attribute for that particular subsystem are fetched by the atts.getValue method of SOX. These attributes are the prefix and name values. For instance, let's list the prefix and name value for the account service subsystem. Once the elements are encountered and their attributes are fetched, our class append HTML code to the menu HTML buffer. This code creates a menu of items using the prefix and name attribute as fetched from the XML. The subsystems are composed of menus and submenus. Menus are single clickable items, while submenus get expanded further into menus when clicked. When the local name variable is loaded by the submenu value, its name attributes is fetched by the atts.get method and it is displayed in the drop-down list of the subsystem. When the local name variable is loaded by the menu, the command and name attributes are fetched by the atts.getValue. The menu item are also displayed in the subsystem drop-down list, but the command attribute particular menu item that is clicked 4-character ID is sent to the green screen. The input to the green screen generates the particular page of that menu item, which in turn is transformed by heads and displayed to the user. Other necessary code for formatting and styling the menu is also appended in the start element method. The end element method also checks for the different values of the local name variables like subsystem, submenu, and menus, and close their corresponding list, anchor, and other text that were opened in the start element method. The end document method marks the end of the table and div tags for the menu that were opened in the start document method. This is how the menu will appear. See the options at root and last level. You can also build the same. So this is it from my side. Please feel free to ask any question.
So from here we can start taking the questions. You can type in questions in the chat window, or if required we can open your mic so that you can ask your questions verbally as well. If anyone wants to ask any question, he can type in the chat window his question, or he can either ask us to open his mic in the chat window so that he can ask us on the call. So we have a question that technically whether JDBC connections can be given through HATS. Yes, HATS can execute any Java piece of code, and we can write some piece of code that can be triggered on certain action, like on recognizing a certain screen on the host. HATS has ability to start executing a certain piece of code, and in that piece of code we can create connection with any database and have data from that database, or we can write a code to consume a web service, consume a web service by which we can get the items for menus or any other thing. We have another question that HATS can also make web services calls too, correct? Yes, yes, Mr. Winwood, HATS can, there can be two sort of web services utilization in HATS. Like we can create web service to extract data from any green screen application. Like we can create a web service using HATS, and HATS will be able to provide a web service for any other software, any other application that can consume a web service. And in that web service, HATS can offer any data from any screen, extracted from any screen of the host green screen system. But here we are talking about a web service that actually the HATS application is consuming, and it is consuming it to get the menu options for a certain user or certain situation. So in our case, the situation we developed and we discussed and we demonstrated in the slides was a situation where our code, our HATS code, was consuming a web service, and that web service may have been generated on HATS or may have been generated somewhere else, and it was providing an XML with the menu options, and based on that menu options we were creating a HATS menu. Okay, we have another question. How clicking the tree menu through JavaScript can have connection to macro? Okay, like any other menu any other link for macro execution. As you know, that hats can any button can be used to trigger a macro. Based on that, hats can navigate to a certain screen or collect some data from host system. Similarly, a JavaScript tree menu can trigger the same button or same triggers the macro. So we discuss about executing a macro in a little detail in our distance learning workshop that Yasir Hassan told you about in the beginning of the webinar. So you can join us in that, and we'll let you know how we can trigger a macro using a click. Or let me see, what questions do we have? Okay, so we don't have any other questions. We were a message of thanks and stuff. So, hope we'll find you guys in webinar sessions and trainings. This is you can see our addresses. Please feel free to contact for any queries. You can get 40 hours of consultancy free of cost from us for any kind of modernization. And let me remind you about our HATS training programs. Stay tuned with us for more trainings and webinars. Thank you very much for your patient listening. We hope you enjoyed the session and it fulfilled what you anticipated with this webinar. Goodbye from all of us. Hope to see you again. Thank you.